Hello, it's Duncan. In the last episode, we implemented a stock repository using the exposed database library, talking to Postgres. This worked well, but every operation ran its own transaction, which is potentially limiting when we want to combine them. Instead, we'd like to insist that calling code manages the transactions, and preferably express that in the type system so that things don't compile if it doesn't. So in this episode, we'll refactor towards this goal, eventually using the experimental language feature of context receivers to solve our problem. I said we had a problem with transactions. Let's try and explain what that problem is. Calls to exposed operations like insert here require a transaction. You look at insert, it says do some things and then execute with the current transaction manager. If we don't have a current transaction manager, we get a no transaction error. Now the way we set up the current transaction manager is to run something in a transaction block like this. But it's not actually passed from here to here. What happened is transaction here is a thread local transaction manager. And the gist of all this jiggery pokery here, horrible as it is to create a transaction if there isn't one running, and then put it into a thread local variable that can be extracted by this insert call with transaction manager current. It says current on null, it says manager current on null, which is, it's defined somewhere, who knows. Now to make sure we've got a transaction to run these statements in, we've created that transaction inside our database items here in save and here in load. That's all very well, but we might want them to run the same transaction. And the nature of this block is that it starts the transaction here and commits it here. So looking at our stock object, for example, that loads the items here and saves them here. And really we'd like those to happen in the same transaction. Okay, having decided it's going to be the calling code's job to set up a transaction, we'll just take these out of here. We've got a block here, unfortunately, so we'll just replace that with a run. And this one is a single expression, so we can take that out of there like that. And now this run, in fact, we can inline. And it will put back in the block for us. If we run that, we expect it to fail because we won't have a transaction for our database items. And there we go, look. Seen this before, no transaction in context. And that context is in the thread local that we would have set up if we'd called transaction. Now, we'd like to fix that by going to the database items tests, but there's nowhere to start a transaction here. Actually, there is a thing we could do, and that is to override each one of these methods in the items contract, which is returns empty stock list and returns last saved stock list. Go back here, and let's say Kotlin any, that doesn't look like what I want. Okay, never mind. Let's copy the names from here. So we've got that one. And here we could say transaction on our database. And then we can say call the super version. It's a bit of a shame that it doesn't complete at this point, isn't it? Never mind. Let's put all these in by hand. Like that. Now this would need to make the superclass version open. Now we'll go back to our items contract, go and get this one, copy it, remember to make it open before we go on. Now our database items test can say I'm going to override that one with override fun that, which is going to say transaction in our test database, super dot this tedious thing here, and run that. And two braces are our problem. Okay, good. So we've got our test running again, but every time we added a new test to our contract, we'd have to add a new one of these to override it. It would be nice if we could work with before and after each. So we could say before each start the transaction and after each end the transaction, but this transaction block commits the transaction as we exit. So we've got no way of doing that, at least not simply with exposed. Instead, what I propose to do is say that in our items contract, we'll run each one of these tests in a transaction block that database items tests or the other tests can specify. So I'm just going to roll this change back, or except that we'll keep the changes to database items where we remove the transaction. Okay. And now in my contract, we'll say in transaction. Now in transaction is a thing we're going to invent. So hold on a moment, just put this in here, in transaction. Now we don't have an in transaction. Let's pass one into here. What would that look like? Well, the value, because we're going to have to remember it, and it's a function type. And we know its name is in transaction. But it's not going to take a transaction. It's going to be a function that takes this block and runs it. So this is a function type. And for now, at least it can return unit. And the thing it's going to take is a block. And that block is going to take no parameters and itself return unit. And you see now this compiles. Okay, let's build and see what that breaks. So here we are in database items tests. Just going to reformat this a little bit so we can see it a bit better. This is our items. And now we have our in transaction. What's that going to look like here? Remember, this is a function type. So we can put in a lambda. And this took a block. And what we want to do in here is run this inside the transaction. So we want to run it in this transaction block like this. So it's going to be transaction on our test database. And we're going to take the block and we're going to invoke it. Now our gratification is going to be delayed by having to do the same thing here. So let's remember that this is items and this is our in transaction. Now in memory, we don't have the idea of transactions. So this can just be something that takes our block and invokes it. We might find a way of making transactions work in memory, but for now we don't. I'm just going to remember that because we're going to do the same thing for our stock file items. So this is our items and this is our in transaction, which is going to be the same as we just did over there. Again, we might find a way with stock file items of setting up some sort of transaction around a lock file or whatever, but that's work for the future if we need it. So now the big question is, does this get our test to pass? And the big answer is, it does. So what we've done is we managed to find a way of abstracting out the idea of being in a transaction so that our contract can specify that needs to happen and individual tests can see what it means to be in a transaction from their perspective. There's still a problem though, and that is that our database items needs to be run in transaction and it doesn't tell us that. It's got no way of communicating that. Now, how could it communicate? Well, functions have three ways of communicating. One is their name, one is the parameters they take, and one is the return type. So we could call this save in transaction or save requires transaction. But what I propose to do is add a parameter to this to remind us that we need to be in a transaction. And I'm going to call that evidence. So we're going to add a parameter and we want to refactor the base. This is going to be, well, actually, what should this be? It seems to me that we don't need evidence for the stock file items or the in-memory items, but we do need evidence for the database items. So they need different types of evidence. So in fact, I'm going to bail from this and I'm going to go to items and I'm going to say items is parameterized with some sort of type, and we're going to call that TX for transaction. It's the type of the transaction or the type of the evidence of the transaction. And now we can go to these and say, I want to change the signature and I want to add, and for now I'm going to call it evidence, and its type is going to be TX, whatever that generic type is in this items. I'm going to leave the default value so we're forced to fill things in later. And let's just refactor that. And we'll do the same thing here. We're going to add a parameter for evidence, and this type is going to be the generic TX and refactor. Okay, let's lean on the compiler and see what we now need to go and fix. Okay, here we are in database items, and the compiler is telling us that we need to specify what the type of the transaction evidence is. One thing we can use is we can use transaction. Transaction is a type from exposed. Put that in there. And then we can fix this up by adding the evidence and reformatting. And we're not actually going to use this parameter here, but we're going to say, if you were clever enough to get hold of a transaction, then you can pass it here, and that's evidence that you have one, and that this code will succeed at runtime. And we can take the same thing and put this line into our load to make that compile. Okay, now what about in-memory items? Well, in-memory items doesn't need a transaction. So we'd like to be able to use null for the transaction, and null has a type, and the type of null is nothing ? So we can put nothing ? in there, and then fix this. And you'll see that here we can pass null as our evidence. Just going to make those back into separate lines. Take this and put it in there as well. And we'll remember this line because we're going to do the same thing in our stock file items, which will have the same problem. So this is going to be items of nothing ? This is going to take a parameter of evidence that can be null. In fact, it has to be null because there are no other types of nothing ? And here again. Compile, and now the callers will have trouble. Now here's our stock. This is a place we actually call load and save. What should the generic type of items be for stock? Well, at the moment, we're only using stock with the in-memory items or the stock file items. And both of those are items of nothing ? So I think we'll use that in here. And that means we can pass null for the evidence in here and null for the evidence in here. So that now compiles. Items contract. Well, this has to work with all three types. So we're just going to punt the type of the transaction up to the items contract. So it's going to share that there. But now when we come to call these functions, we need to provide that evidence. So it seems that the in transaction will have to give us the evidence we need. So we'll call this transaction and we'll pass it into here. And we'll have the same problem down here. So we'll give it the transaction. We'll pass that into there and into save and into the second load and the second save. In order for that to work, this block has to provide a transaction and its type is going to be tx. Now this compiles, we're getting there. Okay, database items now has changed this type, this transaction of database, test database, and inside this block, transaction is this. So we can say block this. But because we made items contract generic, we need to tell it that this is a contract of our transaction from exposed. Getting there. And now our in-memory items test is an items contract on nothing ? This is the type of our null, and here we can give our block null. One last one, same problem with the stock file, items contract on nothing ? And we can give our null evidence to our block because we don't have a transaction. Okay, one last one. These are our stock tests. Our stock tests are using an in-memory items. So here our evidence is null. Another and one more. And now our test pass. Good. Now you might think that it's a bit strange to pass in a parameter here that we do nothing with. And I agree with you. All this parameter is saying is that we're running in the context of a transaction. But context is now a special word in Kotlin because we have context receivers. So let's see what this would look like with receivers, but we will refactor our way there. Go back to our items. I'm going to take this evidence and convert it to a receiver, but a plain old receiver at the moment. And we're going to do the same thing here. Now let's look at our stock file items, for example. This now says nothing ? save and nothing ? load. Well, that's good enough. Our database items says transaction save, so we have to provide one of those. Let's just see whether everything else compiles. Okay, so the refactor actually broke. We haven't moved this parameter to receiver because there's already one here. How do we specify two receivers for a function? The answer is we use a with. What we'd like to be able to do here is we'd like to be able to say with, and the receiver that we want here is null, and that would apply to this whole block here. So there'd be two receivers, one from the with and one from the items. Take that out and take that out. Unfortunately, Kotlin doesn't work this way. Things are back to front. What we actually need to say is with items, and then pass the other receiver in here, that null. This does look odd, doesn't it? But it's what's required. Let's go and fix the test in the same way. So our items contract says in transaction. So we'll move up here and we'll say also with items to here. And this is going to be my transaction.load. So we've reversed things. And we'll remember this because we're going to do it in here as well. That's with items, and this is my tx.save, and it's no longer a parameter, it's that receiver. Same as here, tx.items.load, tx.load without the items. And finally, again here, tx. It's a shame the refactor doesn't work, isn't it, really? But maybe it will in time. And here we're saying tx.load. And once again, remember this items now is being sucked out of this with block. And its transaction is no longer a parameter. Nearly there with the compile. I've messed up something. I'm going to put in a random brace and hope that the reformat sorts things out. And now we have a problem in our stock test that we're going to solve with items null.load. Oh, calling the method. Copy that because it's also going to be there and run. All right. So reminding ourselves, our items now has two receivers. One is the transaction and one is the items. And when we use them, as we do in stock, for example, we have to specify one receiver with and one receiver in front of our method, but they're the wrong way around, which is tedious. Okay, enter context receivers. And in order to use those, we have to change our build.gradle to allow the experimental use of them. So here we are, and a little bit of research shows that we need to add something that looks like that. So we're adding experimental context receivers to the free compiler arguments of compile Kotlin and compile test Kotlin. We'll load that. And now we're going to have to do some more fixing up by hand. We'll go back to our items. And we're going to say, this is not transaction save. It is in the context of a transaction save. And the same is true of our load. Now, it would surprise you to know that will break a lot of things. So database items. This is now context of the exposed transaction save. And confusingly, it's a type, but they are angle brackets, not round brackets. Remember that because we need to put it in here as well. I think technically it should be override context, but the compiler is a little bit broken with respect to its own spec at the moment. Find the next break. That's going to be in-memory items. So this is context of effectively null. Put that in there and take that out of there. Put in the bracket, copy that, put it in here. And I expect JetBrains to give us a refactor for this sometime. Okay. Now null load doesn't work, but we can swap these back to where we really wanted them. So we can say with null items load. So the context receiver is set up in the with block, and the method receiver, if you like, the object to which the message is actually being sent, is the one before the dot. Same problem here. So this is now back to items because our context is being set up at the top level here. And in stock file items, you need to go back to fixing up our items with context of nothing, save, and here, context of nothing, load. How are we doing? Our items contract now, we need to reverse them as well. So here we need to say with my transaction, and this is my items load. Another issue here with my transaction. This is items. Almost there, I promise. This is now with null items load. And it will remember this block here and use it here and here. And we're back to passing the tests. Returning now to our items contract, it's a bit tedious. We have to run this in transaction and with together. And in fact, we don't. What we can say is that this block here that we're going to be calling, instead of taking a transaction, this block can be a context of tx. And now we take no parameters. And now we can take out this and this, because in transaction will provide the context to this items load. I think we'll have one too many of these. And we can do the same thing here. So we can take out that and one of these. Reformat and go and fix up the compilation errors, of which interestingly there are none. Now, I don't understand why there are no compilation errors here. If we look at our database items test, we'll see that we pass the block this here, but I suppose actually this transaction sets the receiver to be the T. Now, I don't know then why we need to pass this in there, but we still need to for some reason. I really don't understand that. If anyone does, please let me know in the comments. But you can see this is really quite convenient. So reminding ourselves then, item says that its load and save have to be run in the context of a transaction, where that transaction depends on the actual type of the implementation of items. Database items says that transaction is an exposed transaction and assumes that the transaction has been set up so that it's in a thread local for these to succeed. Things like our in-memory items don't actually require a context at all, so they just say null will do. One last way this could be more convenient, and that's to go to our database items and say, what if it could provide the transaction for us? Now we know what the signature of that would look like. It's in our contract. So it would be a method that took a block like this. So now we can go to our database items and say this could have a function that was in transaction. It would take the block, the context of our transaction type, which you know is transaction, returns unit, and the whole thing returns unit. And database items knows that it can use the exposed transaction talking to its database. And in that, it can call the block, passing it the transaction. Now, if we were to pull this up to the superclass, what would it look like in items? Move this up here, and in transaction would now take tx, not our concrete type. That will have broken some of the subclasses, I trust. Here's one. Let's override in transaction. And we know here that we can just say run our block with null. And the same thing is true for our other items, which is our stock file items. Okay. Now returning to our items contract, we don't need to specify this because we can ask items to do it for us. So here we can say items dot in transaction, and the same here. And we can remove this parameter altogether. Try running that. And we are good. And that little change allows us to go to the stock, and instead of saying with null, this can now say items in transaction, except it can't because in transaction returns unit. But that's okay, we can fix that. We can say that this has some sort of R, and if our context returns that R, then we will. What does that look like in here? Well, it just means that this is return, whatever this block does. And we'll have to fix the function signature by giving this an R and allowing it to return an R, where this is an R. This now becomes a single expression. One more fix up, I should think, and here we are. This is R equals block null. And I've lost a bracket there. Reformat, remember U, because the one last break is stock file items that we can use the same way. And run. Phew. And one last wrinkle is that we can take the stock tests, and in here we can say items in transaction in order to not need this receiver here. Take that, and maybe we'll just put it around this bit, and this bit, and this bit. Are we done? I think we are. I'm really quite pleased with this experiment. I foresee a few little problems with it. The first is that this database items now reveals this exposed transaction type. So anyone that creates database items will implicitly know about exposed transaction. We could fix that by creating an opaque type that hid the raw transaction, so I'm not sure that's much of an issue. When we end up with different tables in our database, so items and users and so on, then we want the same transaction logically to apply to all of those tables, I think. But that will probably fall out of sharing the same database here. I don't know for certain, we'll find out. Stock here, note does items in transaction, but I suspect that in time, this will become parameterized with a transaction type, and stock list will itself be a context of TX. So that code higher up can load the stock list and then manipulate it in the same transaction. But that can wait until we deploy our database. Right now, though, I think that our stock can work in terms of any item, so we can make this items a star. So maybe that isn't true. Maybe we have to make it items of any. And when it turns out that any is not compatible with nothing, question mark. So let's just go back to where we were. Who can fathom the type system? Back on solid ground and we can check in. Before we do check in, we have to decide whether we're comfortable going ahead with an experimental feature. We've changed our production code to use experimental contexts. Contexts have been around for 3 releases of Kotlin now. I think that as this is a code base that's in active development, it's probably safe to take them on. We've seen that tooling support isn't brilliant, but I do like the way that they express the need for transactions here, and I at least have a vested interest in keeping current with Kotlin features. So providing nobody tells Alison, the owner of the Gilded Rose, that she's living on the bleeding edge, I think we'll be safe. I don't know about you, but this episode has been a bit challenging. I've had to learn a lot. I do want to look at another functional programming way of solving this transaction problem, which is the reader monad. But I think we'll let this all sink in and wait for another episode. If you'd like to see that episode, then please subscribe to the channel. And if you like what I'm doing with Kotlin, then I think you'll like the book that I wrote in that price called Java to Kotlin, a Refactoring Guidebook, details of which are in the show notes below. Thanks for watching.